In this video, we'll be going over the bottom-up array approach of maximum square. So previously, we have completed the 2D matrix approach, and in each of the iteration, we can see that we are only relying on values from rows r plus 1 and r. This means we can use a single array to represent our 2D matrix. Let's go over the dot process. In the 2D bottom-up approach, in each of the iteration, we are only relying on values from rows r and r plus 1. This means we can create a single array to represent our 2D matrix. Then in each of the iteration, we will be replacing the values from the previous iteration. Now let's go over the pseudocode. So we first validate the input parameter. If the input matrix is empty, then the largest square we can find, the area of the largest square we can find is 0, so we can just return 0. And then we're going to create an array length to keep track of the length of all the squares. And then the indices will represent the column. And the values will still represent our length. And then we're going to create a variable max length to keep track of the longest length of all the squares. We're going to iterate through the rows from the last row to 0, which we will denote as r. Then we're going to create a variable prev to keep track of the previous value before we have replaced it at r plus 1, c plus 1. We're going to iterate through the columns from the last column to 0, which we are going to denote as c. If matrix RC is equal to 0, this means the length of the current square will be equal to 0 too. But before we set the current length to 0, we're going to set previous to the current value at length c. Then we're going to set length c to 0. Then we can continue to the next iteration. And then before we update the current cell, we want to create a variable current to save the current value. And set to, and then we're going to set the length of the current square to the minimum value between. Now in this case we're looking at r plus 1 c, which is the length of the current cell, which will be length c. And then in the next one we're trying to find the length of the square to the right. If it's length at the current row but at the column to the right, so it's just going to be length c plus 1. And then for the next one, we're trying to find the length of the square to the bottom right, which is at length r plus 1, c plus 1. And don't forget, in our iteration, this is the previous value before we have replaced it, so it will be equal to prev here. Then we're going to increment length c by 1 to account for the length of the current square. And then we can update max length if the length of the current square is greater. And then we're going to update previous to current, which is the value before we have replaced it. And then we can return max length square, which is the area of the largest square. And then what's the time and space complexity? For the time complexity, it stays the same with our nested for loop, but our space complexity changes because we have converted our 2D matrix into arrays. So it's going to be O of n, where n is the number of columns. This is our length array. Now let's go over the code. So we're still going to validate our input parameter. If the input matrix is empty, we can just return 0 as an area. We're going to still create our variables to keep track of the number of rows and columns and also the maximum length of the largest square. And then we're going to convert our 2D matrix into an array. And then we're going to iterate through from the last row to 0, denote as r, and then we're going to create a variable prev to keep track of the previous value before we have replaced it. So initially going to be 0. And then we're going to iterate through the columns from the last column to 0, denoted as c. If the current cell contains a 0, this means the length of the current square will also be 0. But before we update it, we're going to save the value before we have saved the value, or save the length of the current square before we have replaced it. And then we're going to update the length of the current square to 0. And then we're going to create a variable to save the current value before we have replaced it. And then we want to set the length of the current square to the minimum value between the square to the right, to the bottom, and to the bottom right. This is the square to the bottom, which is at r plus 1. Since we have converted our 2D matrix into an array, r plus 1c will be equal to the current cell at length c. And then for the length r and c plus 1, this is at the current row, but to the cell to the right. This means it's just going to be length c plus 1. And then for the last one is the length of the square to the bottom right, which is r plus 1 c plus 1. Due to the iteration, this is the previous value before we have replaced it. So it's going to be prev. And then we're going to increment it by 1 to account for the length of the current square. And we're going to update the maximum length if the length of the current square is greater. And then we're going to update our previous to the current value before we have replaced it. Then we can return the maximum length square, which is the area of the larger square. Let me know if any questions in the comment section below.